And that was Neil Young, yes?
I don't know.
It was Neil Young. Freedom?
Freedom, and the song title was Someday.
Someday. Neil Young. Sounds like a good thing on a rainy day. I have a number of problems that have been requested, and I don't know just how many of these we're going to get through, but there is at least a duplicity of requests. Oh, that's nice. The page printed, but no message. That's interesting. Okay, I'm going to have to apologize on that one. I went ahead and printed out the request, didn't look to see if it printed correctly, just grabbed it from the feed, and no problem there. 317 is the page number, and one of them that has been requested by at least 2 people is number 34. Okay, and I'm gathering from the comment that that's yet another one. Let me see if I can put that problem under the lens, and let's see what we've got there. Okay, that's centered about as good as we're going to do. 34. So in number 34, I have 5 plus r minus 5s minus rs. Now this is the one of the types we talked about near the end yesterday, grouping by pairs, by 2 terms. And you may look at this, and the thing that's going to be disconcerting, you don't see anything common in the first 2 terms. And that's what makes this one disconcerting. But nevertheless, it is true that 1 times 5 plus r is 5 plus r. Now I take out the common s, and I have a 5 plus r left. And now the observation is that the 5 plus r is in 2 different products. It's in the first product, in the second product. It is a common factor, so I'll remove the 5 plus r and have 1 minus s left, and indeed I have my factoring, which could be written, if you wish, as 1 minus s times 5 plus r. The one thing, again, I'm going to remind you, you must have the parentheses here. You must have a parentheses around the 5 and the r. If you leave these parentheses out, it does not read the same. So I'll be very critical of that. Now, in the papers I just returned to you, there are a lot of glitches I'm seeing. So be very careful. I started out with the idea I'd grade like 10, 20, 30, 40, 50, and so on, and I ended up just catching things all over the place, and the more marks I made, the more concern I have. Watch the little pieces. Just from last night's, the one that seems to be the hardest of the group, m cubed minus 8, to see that as m cubed minus 2 to the third. And then if parentheses are necessary, make sure you have them as part of the problem. So if I had, as an example, 27m cubed minus 8, it's important that you write that as 3m quantity to the third and then minus 2 to the third, that you can't leave this parentheses off here. Okay. Now, even though you may argue it's what you mean, you have to be able to converse with another person reading your work. The only way that they will know that you intended to have the 3 cubed is to have that parentheses around the 3m. So you have to be very careful, not that you don't understand, but that you're communicating what you wish to communicate. Now, there are other problems I have on my list. Do you have any other question on 34? Yes?
Not a question, but on that one I rearranged to 5 minus 5s plus r minus rs.
It can be rearranged. And I could see if you didn't happen to note the 1 as a concept there, you could have said
it was just
5 minus 5s plus r minus rs.
That's what I saw first before.
And that's fine. Then you're going to go ahead and pull the 5 out from here. So if I do that, I have 5 times 1 minus s plus the r times 1 minus s. Now your 1 minus s is the common, and it's just going to be this same product here, but in a reverse form.
Right.
Two ways of doing it. Yes?
When I was doing these, I was going over, I've got these things on cards
Right.
about what you told us
Mhm.
to memorize. I did not see where to start in this problem. That's
The
why
key is 4 terms. Now, if you have 3, it's a trinomial, or 2 terms, a binomial, the rules are pretty well defined. If you have 4 terms, you have 2 approaches you can use. And let me illustrate with one of them that involves 4 terms that could be done in a different way, perhaps. The author has been rather careful to make sure you can't combine things and recombine them. Hunting for something with 4 that could be recombined. I don't see it at the moment, so let me create one. This is just an example, trying to get to what the question is referencing. And let's say I have x squared plus 5x plus 2x plus 12. Yes. Now, if that's a 4-termed expression, what is your first recommendation? Combine like terms. Generally speaking, I mean, you aren't going to leave things unsimplified. So your first step is to say, well, I'll go ahead and do this. And by doing that, I immediately see, since this is 3 times 4, that I have x plus 3 times x plus 4. So when you see 4 terms, you typically try to combine. Now, if I then consider, Debbie, I'll go back to what I had here on the left. If I go back to my original, there is no way I can combine these 4 terms. So the question is it still factorable? You've tried the first goal. First goal, combine, simplify, get something that works better. Second, if you still end up with 4 terms, try taking them by 2 terms together and see if you can factor. Now, I call this grouping, factoring by grouping. And it's simply when you see something that can't be rewritten as a trinomial, then you have basically one option left. Try grouping, and if that doesn't work, it may well be prime. So it's a very unusual problem. If you think of what we typically do, the trinomial and binomials are what you will be factoring. This is of academic interest, just to make sure you can group. But it's not of a lot of practical interest. Any other question on that problem? Okay, in the list I have that I printed, I'll just run to another one. At 72 is another one that was requested that I look at this one. And this goes under the classification of, in fact, I think we talked about this at some point, looking as to whether there is a what? A common variable in every term. And I believe there is. Okay, we have a y squared in every term. And then I believe we have a 12 in every term in 72. So let me write 72 up here now. Let me leave it on the screen just for a moment longer. 72 y to the third, z to the second. Then I have plus 12 y to the second minus 24 y to the fourth, z to the second. Now, as we come off there, I hope you're seeing the common y in every term. And the 12 is a common factor, so I'm taking out 12y squared, and I have a 6y z squared. And what don't I like? The y. That is telling me when I get done here, I'm in trouble. And a 1 and a minus 2, y squared, z squared, and there is nothing that I can do with that trinomial to factor it. Now, what was the one thing I was most concerned about? the yz squared. If it had just been yz, then there might have been some hope. Again, this would have been y squared z squared, so in a trinomial, that's my second degree term. I'd have to have a yz here. Here's my constant. So if this is factorable, and I look at that from the idea of what could it be, and I would more than likely factor out a negative here, put this as a positive, make this a negative, and make that a negative, so this is a positive here. Then I knew that that would have to be 2yz and a yz. This would have to be a 1, that would have to be a 1, and there is no way that I could put signs in here that would allow me to do what? Still, this is in the outside, and I'm going to get a little bit critical here of form. Make sure that each step, all the pieces are written in. There's no way I can get a 6yz out of that at best, and I can't get what? A yz squared. So this tells me that there's nothing here that's working. This trinomial was prime. And I'm answering the question about primeness by looking at it and saying, well, what's the only way I could factor that into binomials? It would have to involve these parts. And there's no way that I'm going to get this as a middle term because of the z squared. Any other discussion on that one? This is not one that you asked for. It was one on my list that I came into the classroom.
I don't know how come I got started with 3y.
Well, you probably saw the 3 instead of the 12. But you should take out the greatest. You should have been able to take another 2 out of each and then 2 again.
Right.
So you just, a 3 would work, but it's not the greatest common factor. And when we say factor completely, it should be the largest you can take out. Yes?
The fact that the negative 1 doesn't have a variable, does that just complicate things even more?
Well, it's just been rearranged.
Oh, okay.
If this had been set up with a z here instead of a z squared, then this would have been 6yz. You then would want to rearrange it, and that was why I took out the negative 12y squared, so this came out as a second degree term, as a positive leading coefficient. So I would have rewritten this. What I would have written there is 2y squared z squared minus 6y z squared minus 1, and hoping that I could factor that. So I rearrange it in a, what I consider a comfortable form. This, of course, could not be done any further, so I guess I should put a line through there. And you need to, in some way, share with me. I saw problems where you tried factorings and then would say prime because the factoring didn't work. Then you need to tell me that that's not the factoring you intended. So for example, and again, these are just things that I'm remembering from looking at papers, but if I gave you this and you wrote this for me, that's your hope that it's going to work. Or perhaps that you wrote this and you tried it and you said that didn't work, and then you told me this. I'd like to see a line through that or something indicating you realize it is not a factoring that's going to work. Otherwise, it's somewhat conflicting information. You give me a factoring and then say it's prime. Okay, back to my list. On my list, I have as another one 75. And I sort of like 75. This is one, as we look at the problem now, you have to see as m plus 1 quantity cubed plus 1 cubed. So number 75 is m plus 1 quantity to the third plus 1 to the third. Now, it's slightly different form than written in the book. But now I recognize it as a cubed plus b cubed, where a is m plus 1 and b is 1. So this is a to the third plus b to the third, and I know that that's going to be factorable into a plus b times a squared minus ab plus b squared, and then it is just substitution and possibly simplification. So I'm going to have m plus 1. This is interesting because I also have what? Plus 1, which is actually going to simplify to m plus 2. So I'll write that immediately below. And this looks much different than you thought it was going to look. Now, m plus 1 quantity squared. Then what? Since this was a plus, this is a minus, so now I have minus m plus 1 times 1, which is m plus 1, which I must keep in the parentheses, plus 1. Now, it's rather interesting because the minus m minus 1 plus 1 is minus m. So this becomes m squared plus 2m minus m, which is plus m. Then I have a plus 1. This minus 1 and 1 go out. So I believe, finally, I end up with m plus 2 times m squared plus m plus 1 because you simplify this into the bottom answer. And that was forcing you to do a couple things simultaneously. Factor and expand a binomial. And by the way, m plus 1 quantity squared as m squared plus 2m plus 1 is called expanding the binomial. Question?
I was just going to say, why wasn't that one square right above your hand?
This one?
No, the other one.
This
Yeah,
one?
Yeah.
It is.
Well, 1 times 1 is 1.
I just didn't
that's
write
right.
the...
Okay.
I will rewrite it. Maybe I will. Yeah. Okay, plus 1 squared, which is 1. But you're correct. It probably is a form. I should have put it as 1 squared. Jennifer? Question? Your expression says there's a question.
Well, I don't know what to ask.
Is it on this problem? Are you wanting to know where I came from here to here? Or is it from here to here?
Well, I thought, okay, if you have the m plus 2 parentheses.
Yes.
I thought that the signs on the other parentheses would be opposite.
They are. It is to here.
Right.
Here's your m plus 1 quantity squared, and then minus m plus 1 times 1 plus 1 squared. But then when I take this, I will take time to do that. I have m plus 2. Now I'm going to take this and expand it. So it's m squared plus 2m plus 1 minus m minus 1 plus 1. Okay? That wasn't a very convincing It's like,
Okay, I see it.
Okay, now that's m plus 2. Now the 2m minus m, the minus sign that you were wanting is going to get lost because I have 2m minus m, which is going to leave you just positive m. Here's my m squared, and then I have a 1, a negative 1, and a 1. So it doesn't look anything like the pattern would suggest. You don't have the m plus 1 as a separate visible pattern here. It collapsed to m plus 2. And the minus sign gets lost because you have the 2m here. That's a neat problem. Other questions on that one? Okay, still going with my collection. Let's go back and look at the document cam. That was number 75. And let's see, in my list, the next one goes all the way back to number 11. So let's come off there for a moment, and we'll come back to number 11. Oh, this is that same concern. Okay, number 11. And this goes back to, Coda, your question. I have 4 terms, and there's not a thing in the world I can do there that's going to lend itself to collapsing it down to 3, correct? But 11's neat. I like that because 11 And this is a good one to have a question on, because this is certainly not the same kind of factoring we talked about in number 34. Because you have to see the first two as a difference of two binomials. So this becomes m plus n times m minus n. And then when you take the 5 out, suddenly things look right. But until you had to see this first, taking that binomial and factoring it. Now once you've done that, you see the what? The m minus n is a common. And you have m plus n plus what? This goes back to that idea that you thought you were going to get what? A binomial, and you ended up with a what? Trinomial. Now that, I'm sure, if you're looking for a binomial and you end up with a trinomial, it's like something's wrong. No, and there's nothing you can do with it. That's as far as you'll carry it. Any question there? Okay, back to the document, Cam. Okay, on the list, I have number, let's see, 32. Okay, let's come to what we have there. The key here is to see an A and a B in every term, and then to see the 15. And Coda, this comes back again to the question, you might see a 5 in every term, or you might see a 3 in every term. You might even see what? The 15 in every term. But the 15 is what you want to see, and then I believe there's an A to the what? A to the third and a B to the second. So the 15A cubed B squared is going to be what you pull out of there. And I would guess that what you have is not factorable. Is that correct when you finish? Okay. Other questions that you have that I haven't covered, and I'm watching my time here. I do need time for the new material. But do you have other questions on the ones you did that you wanted to ask about?
80.
80. Oh, yes. See, we talked about powers of 2, and we talked about powers of 3. We didn't say much about powers of 4 on number 80. But we did talk about this 625 yesterday as what? Well, it's 25.
Cubed. Fourth. The fourth.
No. 625. Let's try this again. What is it the square of?
25.
25.
Okay.
So it's 25 squared, but
Yeah.
25 is a perfect square itself, so it's 5 squared squared, which is 5 to the fourth. Hence, you have a to the fourth minus 5 to the fourth. But that's not really what you should be seeing. Let's go back to the document, Cam, and I'll write the problem on the board. Okay, this is number 80. Number 80. And we have, is it a to the fourth, b to the fourth? A to the fourth. A to the fourth minus 625. I'm going to look at it actually as squares. So I'm going to look at it as a to the second to the second minus 25 to the second. Okay, you could, but there is no special factoring for a fourth power unless you see it as the difference of squares. So I'm trying to focus here on the difference of squares. And so this is going to be, and I'll rotate out of your way in a moment, and this brings up something that I need to discuss. I have a squared minus 25 times a squared plus 25. That's not complete, because the 25 is a perfect square. So the a squared minus 25 I can write as a minus 5 times a plus 5. And the a squared plus 25 is prime. So that finally becomes, I need some room here, a minus 5, a plus 5, and a squared plus 25. And you're going to have a devil of a time seeing that, but Debbie, maybe you can just bring that in and we'll throw it up on the screen so everybody can read it, because I had to crowd that badly. So we'll let Debbie make a cut to that. So a minus 5, a plus 5, and then the a squared plus 25 is not factorable. Now, if you just left it as what you see the next to the bottom line there, I'd have to take partial credit because you didn't factor completely. Let's come back to the document cam for a moment again. Thank you. A to the fourth minus 625. If you saw that as a to the fourth minus 5 to the fourth, then what you'd have to see is a to the second minus 5 to the second. That will work. Okay. It's just not comfortable, perhaps, as a squared minus 25, which I think you quickly see as the difference of two squares. Now, I'm arguing something that may seem a bit inconsistent. 5 squared should be easier to see as a perfect square than 25. But if you're looking for recognition, perfect squares and in your head are 25, 36, 49, the 25 may be more recognizable. What is fairly clear to me as I again look at the papers you turned in from last night, or the night before, the obvious is not necessarily the obvious. We're seeing, okay, I'm going to use a metaphor from computer work. Thinking how my mom used to work with a computer. She would randomly start clicking with the mouse, figuring something's got to work, and just start clicking on, and she could really do damage. This was on a Mac, but she could end up getting things so messed up that I had trouble finding how to get it out of trouble. I needed one of those things they now do. The last save that you did, when you turned off, saved it before, and it'll bring it back up that way. That would work very well for some people. Some of you act like you're clicking the mouse on the screen. You're trying things, and you know the general process. Just, well, maybe it's something like this, but you aren't quite there. And it's the one that comes to my mind is where you see a cube like m cubed plus 2 cubed, but you see the m cubed plus 8, and you don't write the 8 as 2 cubed. You'll write it as 8 cubed or a 5 cubed. Something, you've got to make those little steps. This is detail work at its sometimes worst level of tedium, but you do have to carry it through. Other questions on problems from your list?
Would you go over number 56, please?
56. I'm trying to get the camera so I have minimum glare and also good focusing. Okay, let's try that. 2m squared plus 7m minus 15m squared. This is going to be our infamous FOIL, if it's going to work. So let me go to the sideboard. We'll leave that on the screen. That's number 56. So I have 2m squared. Let me write it first. Okay, let me write and then I'll answer. 7mn and minus 15n squared, and I had number 56. Okay, the question I was just asked, when I looked at that, how did I know this had to be FOIL? I basically ran through the same checklist that I asked you to look for. I asked, is it a trinomial perfect square? The answer is no there because the first term is not a perfect square. I asked, is it a sum of cubes, a difference of cubes? No, because I have too many terms. Is it the difference of squares? No, too many terms. Is it the sum of squares? No, too many terms. Is it 4 terms that I have to use grouping? No. When all else fails, FOIL. So if nothing is recognizable, then you're going to go to the court of last resort. Try to make it work. So I look at the 2 and say that's 1 times 2 and 2 times 1. I look at the 15 and I have 1 times 15, 3 times 5. Those are the only things that'll work, correct? Now, once I've done that, I note the last sign is negative. So this tells me need difference. Okay? So as I look at these, I'm then going to start doing pairs. And I'll write these out for the moment, but typically I look at them quickly and say 15 and 2 isn't going to work, because that's a 13 for a difference. So I don't even worry about it. I go to the 1 and the 2 and the 3 and the 5, and I have hopes here. I feel like Garrison Keillor in Prairie Home Companion. I've got hope here that maybe out of this I will get something that'll do it. And I say 6 and 5, not close. But doggone, if I had a 2 and a 5 and a 3, I could make 7 by doing the difference. And I say, well, then let me jump to this one immediately and say, well, there's a 10 and a 3 and a difference of 7, and I'm in business. But worst case, you could do what? Run the board. 2 of them here, 2 of them here, a total of 4 that you have to deal with. If none of those 4 work, you have a prime. Okay? I'm going to go back to the top of it and reconstruct now my pair of binomial expressions. And I know it's going to have to be a what? A 2, 1, we said. So that's going to have to be 2 M&M. I know I'm going to need the 5 and the 3, but I want the 5 multiplied by what? The 2, so it's going to have to go out here. And the 3 has to come in here. That's how I get the same product I have going here. Then what? I have to have a positive. So that means the 10M has to be the positive one, so that tells me this must be plus, this must be negative if I'm going to end up with the negative 15. Now I left my ends out, which I have a tendency to do when I'm focusing on what? The number part. And if I don't catch myself, I make one of those careless errors. How do I usually try to find that? By going back and multiplying things out and ask, do I get what I needed? And I saw the negative 15, and then I saw that 15n squared and said, oops, need a variable. Now, that is a lot of work to go through just to do that one factoring. But that, as you do more of these, should get very quick for you as a mental process, where you start seeing these products and eliminate maybe 2 or 3 of the possibilities. It's just a tedious process we're going through here. Are there other questions? I'm about getting close to the end of time. Jennifer.
Number 16.
16.
Is it just...
I don't know yet. I have no idea what 16 is. So I'm going to leave this up here, and W will stay there with it. I will go up to the board. 16. Okay. Let me get that under the camera. Oh, yes.
I just factored out the 50.
I would agree. And you get z squared minus 2 left. And 2 is not a perfect square, but we're going to have fun with that. Oh, yes, we are. Yes, we are. Michelle does not like fun, she just told me. Number 16. I just saw something here that I can't pass up. Just can't pass up. 50 z squared minus 100. Because, in a sense, there's a part that I'm hearing in the question. I have a 50, and I do this, and I feel cheated. Right? That's what I heard. Is that all there is? I mean, if all you do is take out a 50, not fair. It isn't. Watch. Yes. Isn't that neat? It's true. In the set of reals even, but not with integers. But we'll be doing stuff like that later. But this was permissible to stop. But if you were feeling somehow cheated, now you should feel better because this is good. Okay. I think I'm going to bring halt to this because I have to have some time to cover new material, and I've been somewhat remiss in not making sure at times that I have enough time left. So will you please pass everything over in the general direction of the front at a diagonal. Okay, we have a new topic. You'll love it. Okay, to the document, Cam. Solving equations and the operational part by factoring. Doesn't that sound great? It is. Okay. We're going to solve an equation, but we need a property here that's a rather important property. It's at the top of page 319. There's a little phrase there that I'm just going to put under the document, Cam, and we'll place that there. Let's see. Let me try to bring... That's okay. Let's try it again, Debbie. I wanted to get rid of some of the keystoning. If AB is 0, two things you multiply together to get 0, then you're guaranteed what? One or the other of them is a 0. So what? I hear you ask. Well, if I can identify that in an equation, now remember the equation is different than an expression. This is going to be critical at this point. An equation is different than an expression. If I refer to a binomial as an example, x squared minus 25, that's an expression you can factor. Now I'm going to write something here on the board in a moment to illustrate the main point. Before I do that, I need to get the, let's see, I need bricks and so on to get this to work. Okay, this is on 318. Let's cut to that, Debbie. This is your general quadratic equation in one variable. ax squared plus bx plus c equals 0. So just generic. ax squared plus bx plus c equals 0 is a what? General second degree equation, one variable called a quadratic equation. A reminder. What was this? General first degree equation, one variable. And just, oh, by the way, what was this called? Linear equation in two variables because it graphed as a line. We're going all the way back into forever, long ago. I asked you to solve for y, and you got the slope-intercept form. That was just a recall. Anyway, here was the original expression I shared with you, just x squared minus 25. Here is the equation. And I should not have placed the parentheses around there. That made something that really wasn't intended. But there is an equation where I have it set equal to 0. Now I could put parentheses around this so that you can see there's no difference. The parentheses are not necessary. Now what do we mean by solving an equation? Well, you find a value of x that makes that a true statement. So in that sense, one way of solving this equation is to look at it. If x is 5, I have a solution, agreed? If x is 5, you put 5 for x, you have 5 squared minus 25, and that is 0. It works. By observation, And finding solutions to equations often can be done by observation. By observation, we see, I hope, that both 5 and what? Negative 5 are solutions. Is that something you can see, at least agree that they are solutions? If you substitute 5 or negative 5 for x, you will get the left side 0. Negative 5 quantity squared is 25. 25 minus 25 is 0, so you have a solution. Is there another way instead of doing by observation? The answer is yes. Let's try it this way. Now, this is not by observation. This is by factoring. So the left side I rewrite as the following factoring. But now, by the property, zero property in multiplication, I have two things that are what? Multiplied together to give 0. Therefore, what do I know? Either one of them could be 0. So I can say then that x minus 5 is 0, or what? X plus 5 is 0. This is a very simple equation. You just add 5 to both sides. So you translate this into x equals 5. Now, what is the predicate logic symbol for or? A V sign. That's or. Do we agree? Two solutions. One value or the other would be a solution. It's a second degree equation, hence two solutions. Not so bad, is it? Okay, Debbie, let's go back to the book. I feel like there's this feeling, okay, if I admit anything, that this is not too bad, it's going to get worse, and therefore I don't want to admit anything. Okay. Remember, we had a second degree equation. Now, what happens if they get more interesting? You have to be careful that when you get a problem like I'm going to show you now, this is in the bottom of page 319. You can't do that one, even though you can factor the left side. That is, you're sitting there with an x squared minus 5x equals minus 6. Let me write up here what we have. Now, this one can't be done yet. Why? What form does it have to be in to use factoring? Has to be equal to 0. It's a quadratic, but it's not equal to 0. It's equal to what? Negative 6. There's nothing I can do with it the way it is. I have to have it equal to 0. So what will I do? Add 6 to both sides, get x squared minus 5x plus 6 equals 0. Then, if there's hope, I have to be able to factor it into these two binomials. I know I have to have an x and an x, and I can have a 2, 3, or a 1, 6. But the key is what? The last is positive. So I have to add, so I can't use the 1, 6, I'd have a 7. Okay? But if I'm going to add, a 2, 3 will do it. Both have to be negative. Then, I want to see the next step, even though technically you could get by without it. I think you can eyeball that and say, 2 or 3 are my solutions. I want to see this next step. X minus 2 equals 0, or x minus 3 equals 0, then x equals 2, or x equals 3. I want to see that. Very important step in the process. there any question there?
You want to see that on the homework as well?
Yes.
That stuff?
Yes, please. For right now, yes.
Can we use or do you want us to use
You
the
can use
symbol?
or. I'm just saving space by writing the logic connective there
Okay.
as or. Any other discussion there? Now let me show you the error that's going to be very innocent. In test, I give you this. Directions, factor. So, next thing I see, and that's when you should stop, do not pass go. You're done. But what will you be tempted to do now that you've done a whole new section of problems where you solved equations? You'll want to tell me x is 3 and x is 2. And I'll say no, because this was not an equation. And that seems fairly straightforward until you get on a test, and then it'll seem to just completely reasonable to go that next step in which I then mark it wrong. Okay, I'll leave that on the board. I have more things I want to talk about in the book. Now, the text many times will consider going ahead and substituting back in to check the solution. These are the directions on 320. You know, they're sort of the 4 steps to happiness. You can think of it more in terms of 3 steps to happiness. Step 1, that's getting 0 on the right side. That's what standard form means. 2, factor completely. 3, then use the 0 factor property to get your solution. The 4th step here is to do what? To check your work. And I'm going to come off there for a moment. Let's leave that up on the screen, Debbie, just for a moment. And I'm going to look at a slight variation on a problem I did earlier. I had this as an equation. But let's say that my equation, and I'm going to go back to a problem similar to what Jennifer asked about, and that is, let's say I had 2x squared minus 50. Now what's your first thing that, if you're going to factor it completely? You're going to take the 2 out, right? And then you're going to have the x squared minus 25. And then you are going to say 2 times x minus 5 times x plus 5. Now I have what? 3 factors equal, well, rephrase that. I have 3 factors in a product, and the product is equal to 0. Now it says one or the other is going to be 0. Well, if I take these, this could be, say, 2 is equal to 0, or x minus 5 is equal to 0, or x plus 5 is equal to 0. Well, can 2 equal 0? No, so that one didn't work, but it still follows the argument. This is not saying that these 3 things are simultaneously true. You're going to go to the show or dinner. One or the other can be 0. You can either go to the show or dinner. If you go to the show, then you have a true statement. Somebody calls you and says, would you like to go to a show or dinner? And you take them to the show. They should not be upset with you because you did not take them to dinner, because you used the word or. And it still may not get you out of hot water, but technically you are correct. Now, if somebody calls and says, would you like to go to a show and dinner, and then only goes to the show, then you have a right to be indignant. There's a difference. We can argue that x is equal to 5, or x is equal to negative 5. But do you notice how I get around the problem? Now, how could you also eliminate the problem? You could have divided what? Both sides by 2. And you say, well, that's good. Why can't I divide both sides by x minus 5? Because if x equals 5, that is a 0, and 0 cannot be divided into 0 in the real number system. You do not divide both sides of an equation by something containing the variable. Now, we're going to come back to that. That's a big issue. You cannot divide by 0, so we'll have to come back. And we are, at some point, going to say, restrict the domain. And you are saying, whoops, where did that word come from? Domain. The domain is the set of real numbers. It's the set that x represents. X is a real number. If I want to restrict the domain, I might say x cannot be 0 or x cannot be 5. We will restrict the substitutions allowed at some point. Again, not a critical issue at the moment. Let's go back to our 4 steps to happiness. I'm not asking that you check your solutions right now, but I'm a little bit concerned because we are developing a process. We are using a process to keep us from having to find solutions by observation. It's like an algorithm. You do long division, and you don't really have a sense of why you do it any longer. You just do it, and it works. At some point, a process may generate what we call an extraneous solution. Now, that's sort of a impossible situation. It is or isn't. How can it be a solution if it's not a solution? But nevertheless, we use the name an extraneous solution, meaning it looks like a solution and really isn't. So it is going to become imperative in the very near future to check solutions. Right now, I want you to develop the skill set for solving an equation by factoring. There will be time to check to make sure that things are working. Please note at the bottom of page 321, as we go there for a moment, Debbie, solution sets are given in problems like this, so let's leave that one on the board. And if I come back to the sideboard here, I can indicate my solution set with braces, and so I indicate the set of numbers that is a solution, and I sometimes use the SS to represent a solution set. So if we look at the book again, the author or authors spell out solution set. SS works fine. Just a little note here on page 320. Not all quadratic equations can be solved using the technique we're using right now. Now, going back to the factoring I did a moment ago, this is, again, Debbie, could you go to the number 16? It's about in the middle, right under the clock. Number 16, could you bring that in the camera for a moment? Think of that one as being an equation where what you're doing right now, if, and I'll just walk over here so I can talk about it on camera, if this were equal to 0 and you factored here, you'd have to stop there for right now because you don't know how to factor that with what we've done, and you'd say no solution. Now, if I can factor this way, I can set these two factors each equal to 0 and say the solution set will be the square root of 2 and minus the square root of 2. So what the technique we're doing right now has limited application. At some point, we are going to take that general second degree equation, which was ax squared plus bx plus c equals 0. We're going to develop something called a quadratic formula that will allow us to turn the crank and get the solutions for any such equation. For right now, we are focused totally on factoring. So again, can we go back to the book for a moment, Debbie? well, that slipped on me, didn't it? Whatever I did there is not, it says can be solved, and it should be not all can be solved by factoring. And it says a more general rule will be given in Chapter 10, and that's where we're headed. There are a lot of problems in here. I think we're going to take a more sane bunch of problems this time. So the homework, we're on page 323. We're going to start with number 13, and we're going to go to 60, let's see what I want here, 66, and we'll do odds. So 16 to 66 in odds, so that's like 17, 19, and so on. 16 through 66 odd. And we'll come back and answer questions on that tomorrow. Debbie, we listened to Neil Young at the beginning, and what do we have for our close?
Wrecking ball.
Oh, the wrecking ball. And all comes down in a pile of rubble. Have a great day. We'll see you tomorrow.